Good morning, everyone, and thanks for joining our campus coffee break. My name is Kathy Tabor, and I'm the Executive Director for the Center for Campus Fire Safety. Today's campus coffee break is called Revolutionizing Fire Detection with ModuLaser Aspirating Smoke Detection. It's by Katerina Turchenko, who is the Kidde Commercial Aspirating Detection and ERCES Product Manager. Before we get started, I just want to do a little bit of housekeeping and let you know all attendees are in listen-only mode. If you have questions throughout the presentation, just type them in the Q&A section of your control panel. We'll get to the questions at the end of the presentation. This presentation is also being recorded. So if the Q&A session does run over 15 minutes and you have to leave, we understand your busy schedule. You will receive a recording within a day or two of the presentation, and it will include the Q&A section as well. To sign up for additional campus coffee breaks, just visit our website at myccfs.org. You'll also find more information about our November Campus Fire Safety Forum in Fort Worth, Texas. Now I'll stop talking, and I'm going to turn this over to you, Katerina.
Thank you, Kathy. Good morning, everyone. Thank you for the invitation and welcome, everyone. Thank you for joining us for our conversation today about aspirating smoke detection and specifically about the Kidde Commercial ModuLaser Aspirating Smoke Detector. Let's begin. Today on the agenda, we have an overview of what aspirating smoke detection is. We're also going to review some of the key challenges and applications for aspirating smoke detection in education facilities. We are hosted today by the Center for Campus Fire Safety, so we will use education campuses, facilities as our primary focus for today, but many of you will see that examples we cover are applicable to many commercial buildings. We're also going to learn about ModuLaser and some of the key features and benefits of ModuLaser that make it a great choice for aspirating smoke detection. And I will close by sharing some of the additional resources with those of you who would like to learn more about ModuLaser after today's webinar. And in the end, as Kathy mentioned, we will do a Q&A session. So what is aspirating smoke detection, or as we simply call it, ASD? ASD is a method of smoke detection that consists of a detector with an aspirator or a fan and a network of pipes with sampling holes, which together continuously draw air into a high sensitivity laser detection chamber. And you can see the main components of an ASD on this visual. They are the detector itself, the air sampling pipe, and the sampling holes drilled into the pipe. Some of the key differences between an aspirating and a traditional spot detector is what we call active versus passive detection. Unlike a spot detector, which usually sits on a wall or ceiling waiting for smoke to reach its center, the aspirating detector actively draws air into the detection chamber using a fan. And this mechanism allows for very high sensitivity and early detection. A spot detector will only detect smoke when it's already dense and is visible in the room. It has filled out the room. In contrast, an ASD will detect fire in the incipient stage where there's very little smoke present in the room. A spot detector, therefore, cannot be used in applications where very early or early detection is required. In those types of applications, you do need to use a device such as ASD. And a visual on this slide helps us put together what we have just discussed. You can see the different types of detection method and the applicability of them throughout different stages of fire. The NFPA 76 standard has 3 main smoke sensitivity requirement levels, and they are very early warning, fire detection, early warning fire detection, and standard fire detection. Thanks to the ASD's ability to detect fire in the incipient stage, it can be used in both the very early warning and early warning applications, in addition to standard fire detection applications. On this slide, you can see some of the mechanics of an ASD detector with an example of ModuLaser. Each ModuLaser detector will have a single inlet pipe through which the air will come into the device. A fan inside the detector is going to draw that air inside, where it's going to reach the filtering mechanism, and after filtering, it's going to enter a high sensitivity laser detection chamber. Once the air passes through the system, it's going to exit through an exhaust pipe back into the protected environment, giving space for the new air to come in. And finally, I wanted to show you how an ASD system would integrate into a fire system, again, using the ModuLaser example. A set of module detectors can be combined into clusters on an RS-485 network. In our case, we call it SenseNet Plus network, and you can see it highlighted in a thin green line on the slide. And then multiple clusters can be combined into a larger network, such as to connect multiple buildings in a campus on a SenseNet network. That's the thin red line on the slide. And we can also connect to a fire control panel with the use of programmable relays. Now let's take a look at some of the key challenges and applications for aspirating smoke detection in education facilities. As I mentioned earlier, many of you will see that some of these examples are very applicable to most commercial building applications. And the first key challenge we're going to look at today is protecting large open spaces. These include atria, auditoriums, gymnasiums, and performance centers. Such spaces are often prone to a physical phenomena called smoke stratification. Smoke stratification occurs in tall rooms where the temperature by the ceiling can get warm, preventing the smoke from reaching the ceiling during a fire event. You can see an example of how this would look like in real life on the larger visual on this slide. You'll notice a smoke ceiling forming right below the area in the room where the temperature gets warm, preventing that smoke from going further and reaching the ceiling, where we usually place our spot smoke detectors. So traditional smoke detectors would not work in such scenarios. In applications where large open spaces are prevalent, we do need to use other methods of smoke detection and ASDs because they have a network of pipes and they can be installed vertically along the walls. They allow for smoke to enter the pipe and the detection mechanism from the sides of the room. They are a great solution for these types of applications. Next, let's take a look at spaces that are challenging for detector maintenance. And these challenges may be due to some physical constraints to access the detector, or perhaps there is a special permit that is required to enter the protected area, or there might be a high cost of interrupting operations in the protected environment. Some examples include elevator shafts, dormitories, laboratories, clean rooms, hazmat spaces, as well as computer and server rooms. Aspirating smoke detectors can be placed outside these challenging to access environments, while the network of pipes is placed on the inside of the protected area, allowing for easy maintenance on the detector and absolutely no interruptions to the operations in these environments. Another challenge that many of you may be familiar with is false alarms and the goal to reduce false alarms in commercial facilities. False alarms can be costly, they can be disruptive to campus operations, and they can also lead to tampering with detectors to desensitize them. Aspirating smoke detectors, in addition to having that filtering mechanism that helps prevent large particles like dirt and dust from reaching the high sensitivity detection chamber, they also have flexible sensitivity ranges that can be adjusted according to the ambient environment in the protected area. ModuLaser specifically also has a dust discrimination algorithm that helps us further reduce the occurrence of false alarms. And finally, the ASD piping network can also be strategically placed to help minimize tampering with detectors. And finally, many public commercial buildings have these high traffic areas which can add difficulty to safe evacuation in case of a real fire event. Panic and injury are possible in these spaces. So by detecting fire in the incipient stage and enabling zone localization, ASDs give facilities such as large campus buildings more time to first safely evacuate building occupants, and second, quickly identify the source of fire to avoid extensive property damage and repair costs. Now that we have looked at some of the components and applications for aspirating smoke detectors, let's review ModuLaser and some of its key benefits and features that make it a great choice for your ASD needs. We are going to focus on four main advantages of ModuLaser today, and it's the reliable early detection, reduced false alarms, scalable design, and its cost effectiveness. ModuLaser design and support team has over 30 years of experience in aspirating smoke detection systems. We have installed over 100,000 ASD devices throughout the world. We trust in the high quality of our product, and we show that level of confidence by offering a 5-year extended warranty for our ModuLaser product. But most importantly, ModuLaser was built with the end user in mind. There's only one inlet pipe per detector module, which means there are absolutely no delays to localize which zone in your building is an alarm. And this means faster localization of smoke and more time for containment actions for your facility. ModuLaser is compliant with all applicable North American fire codes and standards, including the UL 268 7th edition. And our user-friendly pipe network design software enables installers to select an applicable standard when building the piping network to ensure that your facility gets optimal coverage and ASD system performance that meets all necessary code requirements. One of my personal favorite features of ModuLaser is its patented classifier algorithm, which uses machine learning to analyze the ambient environment in the room and adjust the sensitivity levels of the detector accordingly. The algorithm is also capable of identifying and discriminating large particles like dust, further reducing chances of false alarms. And why is this important for your facility? If your environment changes over time, let's say your facility undergoes a construction project, or over time you start seeing an increased or vice versa reduced building activity or building occupancy, the original sensitivity that was set in your detector during commissioning may not be optimal over time. With classifier, there's no need to worry about the environment changing and affecting detector's performance because classifier continuously monitors the environment in the protected area, and it makes small incremental sensitivity adjustments as needed. ModuLaser is also a scalable and customized solution. It is fully backwards compatible with our current ASD product range. It can be a standalone or a networked solution, and it can be connected to a fire control panel. Modular design allows for a wide variety of combinations of the detector modules combined in non-distributed or distributed clusters, allowing for more flexibility, scalability, and easy expansion of the system in the future. And finally, both the installers and facility managers can benefit from lower installation costs thanks to the modular design that allows for more flexibility. And maintenance will also be at a lower cost because one module does not impact the rest of the system. So when we are doing maintenance on one module, all other modules remain functional and continue protecting the area. The system also does not need to be powered off during maintenance of a single detector module, allowing for continued operations in the rest of your facility. And with that, I would like to share some additional resources with you if you would like to learn more about ModuLaser after today's webinar. If you have any questions, please feel free to reach out to me directly. My email is katerina.turchenko@carrier.com. And if you would like to learn more about ModuLaser on your own, please feel free to scan one of the 3 QR codes you're seeing on the screen. The first one will take you to the Kidde Commercial website. The middle one will take you to the ModuLaser brochure, which covers some other applications we haven't had a chance to discuss today. And the third one will take you to our ModuLaser overview video. And with this, I'll turn it over to Kathy to begin our Q&A session.
Thank you, Katerina. Very nice job. And I have to say, you got a comment that came in from one of my oldest friends in the industry who said the same thing. Nice job, Katerina.
Thank you.
And it looks like we have quite a few questions, well over the 10 that we usually go through. So we'll go through as many as we can. If they keep coming in, we may have to stop the session at some point. But all the folks at Kidde will receive all your questions and they respond to everyone within a week of our webinar. And also, as you all know, we are definitely recording this session and a copy will be sent to you by the end of this week. So let me start with the first question and see how far we can get. Can you explain how the filter works and how much of the inlet air is being sampled?
Sure. So the main purpose of the filter mechanism is to ensure that large particles like dust and dirt do not reach the ASD's high sensitivity detection chamber. With ModuLaser, we have a 4-layer filter to help us make that process even more effective. And we also implemented a wastegate technology where we only sample 10% of all incoming air. The rest 90% never goes through the filter, it exits the detector, and that helps us reduce maintenance cost by making the lifespan of a filter longer. So that's another cost reduction point for facility managers and installers.
Okay, and the next question, are there any regulatory requirements or standards that educational institutions need to adhere to when implementing aspirating smoke detection systems?
Okay, there is no one single requirement for all education facilities. Your local authority having jurisdictions will be the primary source of information for your specific local requirements. In addition to the NFPA and IFC requirements, of course, these local requirements do vary by state, by county, so there is no universal one requirement that's applicable to all education facilities.
Okay, next. What is a typical response time of an ASD when it detects smoke?
The response time is going to depend on your application and specifically the requirements to which your application was installed. For example, if you select the very early detection standard for your application, you must meet the 60-second transfer time requirement. For early detection, it's 90 seconds. So it really depends on your specific requirements for your application and your installation.
Okay. Is ModuLaser a good solution for spaces such as libraries, theaters, old historic facilities where interior preservation or discrete detection is important?
Yes, ASDs and ModuLaser are a great solution for such scenarios. If you had a chance to scan the middle QR code with our brochure, we actually cover that application in the brochure. You can opt for a natural color capillary tubing to help make your air sampling discreet. You can also opt for installing your piping network above a false ceiling or below false floor, and that will also help you make your detection concealed.
Okay, and here's a kind of a common question. How can aspirating smoke detection differentiate between smoke from a real fire and false alarms caused by other factors like maybe dust or humidity?
Okay, so we have discussed the filtering mechanism earlier, and that is really the main barrier for large particles like dust or dirt before they can enter the detector. If we're talking about different environments like humidity or moist environments, there might be some special sensitivity settings required based on that specific application. We also might require a water trap. So if we know the environment is wet, there might be these additional ancillary parts that might be required as part of the installation. In very moist environments, we also might have to require to invert the placement of the detector and also possibly install additional inline filters. So yeah, it really depends on the application and the amount of moisture in your environment.
Okay, how does the maintenance of aspirating smoke detection systems compare to traditional smoke detectors?
There are some similarities and differences. The similarity is that you do need to do the annual testing of the detector. You do it by smoking the furthest sampling hole from your detector and measuring your transport time. So the time it takes from that smoke sample to reach an ounce on the detector. And then you compare your measurement to the one you noted down during commissioning and making sure you're still within those required limits. Another component to maintenance is the cleaning of the pipes, sampling holes, and also replacement of filters. These components do vary by the environment, so the frequency of how often you need to do that does depend on your environment, but it is recommended to replace a filter at least once a year.
Thank you. And we have a few questions on UL 268, so I'm going to combine them into one, and it's, is ModuLaser fully approved under UL 268 7th edition?
Yes, this is a great question. We are fully approved. We were one of the first ASD systems out there to be approved under UL 268 7th edition. So we are fully on board going forward as it relates to this specific requirement.
And how does the cost of Kidde's ASD compare to others on the market?
We are very cost competitive thanks to the flexible design and other features that reduce maintenance on ModuLaser detectors. Please reach out to us after the webinar and we'll be happy to help you with the quote for your specific application.
Okay. And are ASDs resistant to nuisance phenomena associated with steam?
Yeah, so I have mentioned this in one of the earlier questions. So it really depends on the amount of steam present in the environment. ASDs can be effectively installed in applications where steam or condensation, for example, are present, with careful consideration for the detector placement, sensitivity levels, and any additional components that might be necessary in that application, such as additional inline filters or water traps.
And how would ModuLaser integrate into a fire alarm panel? That's a question that was asked a couple of times too.
Okay, so currently fire control connectivity can be achieved by monitoring detector contacts using addressable monitor modules and hardwired zones. We are also working on additional ways to integrate ModuLaser into the panel, and we'll be able to share more on that in the future.
Okay, and we have about 12 more questions, so I'm going to do 2 more, and then what I'll do is send you guys the list of questions and you can respond to everyone.
Sounds good.
The next one is, can you provide more information about the cost of implementing an ASD in an educational facility?
So the cost will depend on many factors, including the size of the protected area, the environment in which it's installed, whether it's a retrofit or a new installation. What I can say is ModuLaser's flexible design and extended filter life makes the installation and maintenance very cost competitive. For any specific application questions and a quote, please reach out to us after the webinar and we'll support you on that.
And last question, are there any limitations or scenarios where ASD might not be the ideal solution for campus safety?
ASDs can be installed in any indoor environment in an educational facility thanks to the wide range of sensitivity levels and the flexible design. However, if you have any specific concerns about a certain application, please feel free to reach out to us. We're going to review it with our team and provide you tailored guidance based on your specific requirements for your application.
Okay, and we have about, I guess it's 10 more questions. We will get back to you. We need to just call it a day for this presentation. Katerina, thank you so much. Great job. Thank you everyone for attending. And you will all receive a copy of the video. You'll all get your questions answered, and you'll all have Katerina's contact information.
Thank you, Kathy, and thank you, everyone.
Bye-bye.